All right, well, good afternoon, everyone. Welcome back to another exciting day in mathematics. Warm-up number 49 is on the screen. Let's get cracking. That shouldn't take us more than about 6 minutes, hopefully. Give you guys some time for that. Copy in. All right, let's see. Where are we at? We need standard deviation. We need variance. We need a bell curve. Whoa. Oh my goodness. Hold on. Let me start all over. No. All right. Let's see. Yeah, a little bit better. All right. Let's see. Mean. What'd you get for the mean, Jess? Okay. Yeah. What was it? 80. Hands if you got 80 for the mean. All right. And then we need standard deviation. Oh, variance. Oh, sorry. First the variance. Let's do pass someone, Jess. Jared, variance. 12.8. Hands if you got that. Variance? No? Let's see. Help them out. Oh, Samuel. Go, Samuel. Variance. 1,405. Like that. Hands if you got that. Well, we good? Yeah. Okay. What did you get, Andrew? 125. 125. Hands if you got 125. Looks about right. Yeah, that's the variance. So standard deviation. Zach. 11.18. 11.18. Hands if you got that. Looks about right. So on the normal or average from here to here, it's from 68.82 to 91.18, and that's our average range. And then we go one more for the above average and above average. Okay? All right? We good, yeah? So we're about to move on. I think we hammered standard deviation pretty well today. We're just going to get 2 more formulas. Come on, let's go. 1 more formula. All right, here we go. Our agenda for today, warm-up number 49, measures of variation. Home play, page 145, numbers 32 to 35. It's only 4 little itty-bitty problems. All right. Copy that. All right, so home plate, page 145, numbers 32 to 35. There's a lot of people missing today, so I'm going to hold off on the retake from yesterday. We're going to do that tomorrow. Yes. But I do want to get us started. Give me a second. Here we go. On Cornell Notes, I can summarize data and compute the measures of variation. Today we finished with this section, by the way. Let's go. And we're moving right along to the last section, which is measures of position. That's coming up. So measures of variation, we already know what they are. Yes, tell your neighbor measures of variations. The three, please. What are the three measures of variation? Okay. And tell your neighbor the three measures of central tendency. Three measures of central tendency. Yeah. Yeah, we got that, right? Yeah, so basically we've been through here, here, and we're headed here. So today we're going to be the last section of variation, measures of variation, moving on to position. And last thing we saw yesterday was coefficient of variation. And we added two more formulas to our plethora of family of formulas. Yes? Look at that. It looks nice, huh? Well, today we're going to add one more. One more, you know, just to kind of like close this section nice with a cherry on top. Yes? Yes, is it cute? All right, so before we move on, though, I think I remember it was like the second week when we introduced the standard deviation, and we went with, I said, here's a normal curve. Some of you were still kind of like trying to figure out, you know, this course as to where we were going. But I did introduce a normal curve. Here's a normal distribution bell curve. Look up to the screen. And I said the average is usually within one standard deviation right here. That's why we keep saying this is the average from here to here. So it goes from standard deviation up 1 and minus 1. That encompasses 68.26% of the total. How much? 68%. When you go to two standard deviations up and two down, it encompasses 95.44%. And then if we go to a third standard deviation, that is 99.72%. And that's the normal distribution curve. And once again, you have these notes, I'm pretty sure. However, today we're going to compare this to one distribution that was brought up by a Russian mathematician. So we're going to talk about Chebyshev's distribution. Chebyshev's distribution. So write that down. Chebyshev's distribution. Now, according to Chebyshev's distribution, it is not a normal curve. He said that the curve doesn't matter what the figure it forms. His distribution is based on standard deviation and a little formula he came up with. And this is what he came up with. He said, if we have data, here's the mean. The shape of the curve does not matter. Let me repeat that again. He said that the what? The shape of the curve. So I want you to make me a curve, start it off, and finish it off over here, and it doesn't matter what it looks like in between. There's mine. Because according to him, it doesn't matter. Okay? But what he did say that the percentages that he gives are different from the normal curve. The percentages that he said go by, he says that he doesn't start at the 1 standard deviation, he starts at the 2 standard deviation, at the second one. And he says that his percentages from here to here are 75%. The third standard deviation, he says for him, it's 88.89%. All right. Now, how did he come up with those numbers? Well, I'm going to show you the formula that we're going to add to our tool belt today. But that's what he's talking about. But look, let's compare it to the normal curve. 2 standard deviations, how much percent is it from here to here? It's 95.4. But according to him, he says that no, 2 standard deviations, we only have 75% of the data within those. 3 standard deviations in a normal curve is 99.7, whereas to him, he said, no, it's 88.89%. Okay? Today we're going to be focusing on his distribution for standard deviation, and we're going to see 2 different types of problems that we're going to be doing tonight for home play. Let's go! Because tomorrow is what? That's good. Hey. What is it? Anyways, copy this formula, please. Chebyshev's theorem states 1 minus 1 over k squared gives us the percent of that curve that we just said, which is not a normal curve. It's just, it doesn't matter the shape. That's the distribution that he gives. And k has to be greater than 1. That means that he doesn't go with the first standard deviation. He goes beyond that, more than 1. Now, k stands for the number of standard deviation. Notice that I said the number of. I didn't say the value, because in the warm-up we found what? The value, right? Whereas here we're trying to find out which standard deviation it was. So it's a little bit different, okay? So check this out. So let's use this. I'm going to go back to the previous screen so you guys can see how he got those percentages. So 1 minus 1 over k squared. So let me go to the previous one. Here's my graph. Does the shape matter according to him? No. So he says, if I use the formula 1 minus 1 over k squared, k being the number of standard deviation. So in this case, he said, this is the what? The number 2. So if I substitute for k2, I get 1 over 2 squared. What is 2 squared? 1 minus 1/4. So what is 1 minus 1/4? 3/4. That's in decimal what? 0.75. And how much is that in percent? Times 100. That's how he came up with that number. Therefore, check this out. To get 88.89%, tell your neighbor what we're going to substitute here for k. What would we substitute for k? Everyone? 3. So we would do 1 minus 3 squared, which is 1 minus 1/9, which would be point blah, 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 which in turn turns into 88.89%. Is that correct? Yeah? And so on and so forth. Okay? So here's the thing that you need to remember. When somebody says, according to Chebyshev, and says 75%, tell your neighbor what standard deviation they're talking about, according to Chebyshev. Everyone? Yeah, so you would say k is 2. That is correct. Whereas if they say, look at 88.89%, so what are we talking about in regards to k? 3, and so on and so forth. Okay? So keep that in mind because we're going to use that information right now. Copy this, example Q. Mr. Q stats formula parte had a mean score of 85 with a standard deviation of 4.5. Identify the ranges or the range of grades between which at least 75% of students scored. And this is pretty close to yesterday's scores. And you're writing that down? Okay, good. All right. Once again, it says, Mr. Q's statistics formula parte had a mean score of 85 with a standard deviation of 4.5. Identify the range of grades between which at least 75% of students scored. Okay? So, check this out, guys. Whenever we have this, look up to the screen. We're going to do this by hand. Ready? First of all, we need the mean. Second, standard deviation. Third, percent. And fourth, K. So with that said, tell your neighbor what the values for all those four are according to that problem. Talk it over to your neighbor. What are the values for that so far? All right, so I heard 85, so far so good, yes, because it says mean. And then 4.5 for standard deviation, yes. Percent, 75, okay, we got that. And K, everyone? 2, that is correct. All right, so now that we have that, this is what we're going to do. They want to know between what ranges. So that means, check this out, I'm going to sketch just a line here. Let's put the mean here in the middle. The mean is 85. Okay? So what is given? What's given is that they want to know from where to where the scores fall that give us 75%. 75%, that's what's given, yes? So we know that it's how many standard deviations? 2. So we go 1 and 2. One and 2. Okay, we good? All right. Now, this is the easy part because we've been practicing this. This is what we've been doing the warm-ups for. So here we go. What is standard deviation of 4.5? So what do we go for the first standard deviation, which is here? What is that? 89.5. That is correct. But since they said it goes to what? 75%, which is what? The second standard deviation. So what is that number here? 94. That is correct. Now find me the other n. Find the other n, please. Like we did with the curve. Yeah. All right, Mel, give us the negative standard deviation. 80.5, and the negative second standard deviation, Cheney. We're going back that. 76. Yeah? So, from where to where? From 76 to what? So our statement would be 75% of grades fell between 76 to 94. Straightforward. Like I said, we've been doing this with the bell curve for the warm-up, so this is straightforward, and I'm pretty sure we got this, yes? From 1 to 5, how comfortable are you with it so far? Yeah. Okay. I'm going to give you one. Very like it. You don't have to copy the problem, but just start writing down the information, set your distribution, and find me a statement at the end. Here it goes. And it reads, example, super Q. Mr. Q's algebra 2 transformations parte had an average score of 80 with a standard deviation of 3.2. Identify the range of grades between which at least 88.89% of students scored. Copy that and go. I'll give you some time for that. I forgot to get you guys started. Here it is. All right, so let's see. The mean is, or the average is what? 80. 3.2 for the standard deviation, yes. Percent, 88.89. And what does that mean? That K is what? 3. That is correct. So if we start at 80, and we're going 3 standard deviations, yes? 1, 2, 3. We want to know what that n number is and what this other n number is. Is that correct? Because what did they give us? They give us the 88.89%. All right. So, let me pause that really quick. So if we go standard deviation 3.2, after 1 standard deviation, 2 standard deviation, 3 standard deviation, so that is 3 times 3.2, that's 9.6, is that correct? So that lands us at what? 89.6. Hands if you got that? Yes. Or just go 3.2 at a time, so that is 83.2, and this is 86.4, and we end up at 89.6. So now we have 9.6, take away that from 80, that lands us at 70.4. Yeah? So therefore your statement, the scores, 89, 88.9 fell between what? 70.4 to 89.6. From 1 to 5, how comfortable are you with these? Yeah, 5s, right? We got this. Okay, now check this out. This, they give us all the information, and all we have to do is pretty much just count the standard deviations and come up with the n numbers. Well, now they're going to give us a problem where they don't give us the percent or the standard deviation, but they give us the end values, and they give us the first 2 standard deviation and the mean. So copy this one, please. Example 2Q. And it reads, a survey of local companies found that the mean amount of travel allowances for couriers was 0.25 cents per mile. The standard deviation was 0.02, and using Chebyshev's theorem, find the minimum percentage of the data value that will fall between 20 and 30 cents. Copy that, I'll give you some time. So, to get started, let's start with organizing our information. We need a mean, a standard deviation, percent, and the number of the standard deviation. Okay, so do they give us the mean? Yeah, the mean is 0.25. Standard deviation, yes, 0.02. Do they give us a percent? No. Do they give us the number of standard deviation? No. Okay, well, let's start everything the way we started the other one. Here's our distribution line. We are at 0.25. But what do they give us in the problem? It says, using Chebyshev's theorem, find the minimum percent of data values that fall between what numbers? 20 and 30. That means that they give us the end numbers this time. So what is the beginning? 0.20. And what is the end? 0.30. So in this case, they do give us the end numbers. What is it that they don't give us? They don't give us the percent compared to what we just did earlier, right? So to get started, first of all, we need this distance to find out what K is. So how do we find that distance? Tell your neighbor. Yes, you do. Look at the numbers. If I was to ask any somebody to give me the distance from here to here, what would you do? 0.30, what? Minus 0.25. That is correct. You subtract the largest amount, which is the end, from the mean. So write that down, please. So what is this? This would be 0.05. All right. So what does that mean, Mr. Q? That means that from here, from the mean to the end, that's so many standard deviations. We don't know what they are. I mean, we don't know how many standard deviations. Do we know the value, though? Yeah, the value is 0.02. So what do I do to this, given 0.02, to see how many standard deviations? So what do you guys think? Divide. That is correct. So divide by 0.02. And that's going to give us our what? K. So 0.05 divided by 0.02, 2.5. All right, so what does that mean, Mr. Q? Well, it means this. Look up. That this score is at how many standard deviations? 2.5 standard deviations. 1, 2, and then the third one's over here, so halfway there is 30. That's what it means. All right, but is that what we need? No, what do we need? Yeah, they want the minimum percent that these two numbers represent. So how do we find that? Well, that's where we get our formula. 1 minus 1 over k squared. Remember that we started with this at the curve? So, tell your neighbor what to write for that. 1 minus 1 over 2.5 squared. Okay, calculators, help me out. 1 minus 1 over what? 6.25. All right, so subtract 1 minus 1 over 6.25. What is that in decimal form? .84. So what does that tell us? What's our percent? 84%. That is correct. And then you would write a statement. The percentage, the numbers 20 to 30 are found between here and here with 84%. From 1 to 5, how comfortable are you with that? 4 5s, 4 5s, okay. So let's go through the process one more time. We needed these 4 pieces of information. They only gave us 2. How do we find k first? Well, we first got our mean, and then the ends were 20 and 30. From there, I went from the mean to one of the ends so I can find the standard, how many standard deviations. So the standard deviation from here to here was 0.05 divided by 0.02, and that gave me the value of k. Once I found that, I substituted into the formula, found my decimal, and that's how we found our percent. All right, I'm going to give you another one. You don't have to copy it, but you have to do the process to make sure you got it. Okay, here's example 2 super Q, and it reads, trials to learn a maze. The average of the number of trials it took a sample of mice to learn to travel a maze was 12. Once again, the average number was 12. Standard deviation of 3. Using Chebyshev's theorem, find the minimum percent of data values that will fall in the range of 4 through 20 trials. Very similar to the one we just did, different numbers. Go through the process. I'll give you some time. Get help from your neighbors. Go. All right, let's see. We got our mean, which is 12, yes. Standard deviation, 3. We need a percent, and we need K. Okay. So the mean is 12, and the ends we have 4 and 20. Is that correct? All right. So what's the difference from here to here? That's 20 minus 12, and that gives us what? 8. And we're going to divide that by 3, and that gives us K, yes? So K was what? 2 point what? 2.67. And then from there you use 1 minus 1 over 2.67 squared. And that's going to give us a percent, yes? What's the decimal of that? 0.86, so therefore this is 86% from here to here, 86%. Hands if you got something like that? Yeah, we got it, yes? All right, so tonight's home play is basically those two types of problems. I gave you 2 of each so you can practice. All right, and we'll stop right there. Yes? Get ready for tomorrow, which is what? Zach?
Friday. On Friday.
All right, we'll stop right there.